Diego, if I could interject, the FEAT version 1.1 that I've downloaded is in Spanish. So the first one is in English, the pocket is in English, but the second one.
The second link is in Spanish. The original, let me see, sorry. Probably I shared the wrong link. Thank you for letting me know. Version 1.1. You mean the 2009 version? It's in Spanish, the link.
Yes.
Okay, sorry. I will share the link to the one in English. Thank you. Anyone at the link now? Apply. Copy. So I just pasted in the chat, put in the chat a different link. Can you check if this link, it's the version in English, please? Check.
Yes, Diego. I think this one is in English.
Okay, great. Thank you so much. So now we're recording. Sorry, I forgot to start recording from the beginning. The other utility for this is it focuses on the immediate impacts of the release of hazardous chemical materials like oil, petroleum, mercury. It allows emergency actors to decide on initial risk management actions. It allows for pre-emergency analysis that increases preparedness and response capacity if necessary action is taken. And it allows the disaster response personnel on how to conduct rapid assessments in the field. And that's why we launched the smaller version, the pocket version of the FEAT, because it's very small. You can take it in the field. And as you will see in a moment, if you don't have the name exactly of the chemical that is being probably spilled, you will find two other options to get that information. So the FEAT tool is based on a triangle of impacts. So the impact at the end that you will find after putting the information, it's a function of hazard, of the quantity, and exposure. If you have the three of them, you have the impact. If you lack only one of them, you don't have any impact. Because for example, let's say you have a hazard, a chemical, you have a quantity, it is stored, but you don't have exposure, you don't have an impact. Or if you have quantity, you have exposure, but you don't have a hazard. I mean, that wouldn't be logical to have a hazard and not having a hazard, but having a quantity, you wouldn't have an impact. So you need the three of them to have the impact. And the impact is defined as significant acute or long-term effects on humans and the environment. And as you will see in the exercises we're going to show you, the names and the results will, with the name, it will show you acute or long-term, depending on how the effects will be. And there is only a significant impact if all of the three factors are present. So now, I'm going to explain you where the estimations came from, these estimates. Because the FEAT, what it will give you are distances, numbers. So it's a collection of a lot of mathematical, physical, chemical relationships, equations, and everything. And after putting two inputs, you will get a number. And those numbers came from these estimates in the air, in the water, and in the soil. So in the air, assuming a stable climate and a wind speed of 5 meters per second and a class D of Pascal stability. In the water, there were two assumptions. The first one was assuming a standard lake with a depth of 1 meter and a cylindrical shape, and the distance that the FEAT tool will give you is the radius of the lake. And the second one was assuming a standard river with a depth of 1 meter and a width of 50 meters. And the critical impact distance is the length of the affected river section. But you may say, okay, I have a many lakes in my country, and some of them are 3 meters in depth or 50 centimeters in depth. So how these estimations from the FEAT can work? Well, Juan Carlos is going to explain you later how these differences in geometry of the body of water bodies will change the estimations from the FEATs. For example, if you have a bigger depth of water, so the radius of affected or impacted area would decrease because you have more water to dissolve the chemical in the water column. But all of these also depends on temperature, densities, climate conditions that you also need to take in consideration and include in your analysis. And finally, the assumptions for the soil was that assuming a standard scenario, that it was based on the base scenario of the lake, but assuming that the dispersion would occur through a small layer of water of 2 centimeters on the land. So these three estimates were the base for all the numbers or all the calculations of the FEAT. Do you have any questions so far? Just remember, just open your microphones at any time, interrupt me. I'm gonna put the chat here open just in case. Okay, so the step-by-step explanation here, I'm gonna ask you to download the FEAT Pocket Guide, the smaller version, the one launched in 2017, and I'm gonna give you the pages where you can find the information. So the step one is determining the most likely hazard. But before continuing, I would like to ask if all of you could download, or if someone had any problem downloading the file. Okay, so probably the link worked for this version. So the step one is determining the most likely hazard, and there are three options to determine this. The hazard can be determined using the name of the substance, the type of hazardous operation in place, or the pictogram. The FEAT Pocket Guide will give you three tables in order to get this information. For example, if you don't have the name of the substance, because there may be 100 industries in just a specific area in your country, and there's an earthquake, you probably don't know which substance specifically that industry is handling that is probably being leaked. So you have probably the name of the industry, of the facility, and you know probably what they do, and that would be in the hazardous operation. But if you don't, and there is a pictogram, you can use that information. So right here, we have three tools that can be very useful to determine this. So I'm gonna show you in which pages you can find the three tables. So the first one is the table of substance table. It is on page 21. And in here, depending on the substance, so let's say it's acrolein or allyl alcohol, or I don't know, benzene, or any chemical substance that is on this table that has 9 parts. So it's a kind of like long list. You will find, and you can find in here the type of substance that is being used. For the bigger version, there are more chemicals. So this is kind of like a little bit shrinked list of chemicals. But if you need something that is not in this list, you have the name, you can use the bigger version that I'm going to explain in a moment. So after finding the let me see if I can use the pointer. And what is it? I see here.
Excuse Diego,
Yes.
one that you just give us to download 78 pages, that's the long version or the short version?
The one that I'm explaining now is the short version.
78 pages?
Excuse me?
The one that you just gave us to download, 78 pages.
The standalone link is for the bigger version because I posted the link in Spanish by mistake. But this version I'm explaining now is the link that it says FEAT Pocket Final. Could you download that?
Yes, I got the file, but I'm just confirming if it's the long version or the short version that you're making reference on this slide.
Right. Oh yeah, right now it's the short version. It's
okay.
Short. Pocket. Yes. So after finding the substance, you will find two results in here that are very important and that will help you continue in the process. The column of hazard classification for the first priority and for the second priority. So you write down this, it has a weird name, but that's how it is classified: acute, tox 1, and aquatic chronic one. This is the result. This is what you need to continue. But you can also read the physical state of the substance, if it is in gas, liquid, or solid state, the other hazard classifications, but these two are the more important and the first priority you have to focus on. But there are many other that are related to this substance. Then, if you don't have the name of the substance, you can go to page 41 of the short version and hazardous operation. And let's say, on this place, I'm sorry. Okay, I thought I heard someone. It's a beer production facility. And it's a beer production facility. You don't know which chemicals they're using right now, but the FEAT will give you the most common substance for this type of facility. So in this case would be ammonia, which is in gas state. And then you will get from here again the hazardous classification that are for the first priority, for the second priority. Some cases you only have for the first priority according to the characteristics and most needs for this specific response. So you would write down acute tox 1. This is the result you need from this. It's the same as before. You write down the hazard classification that the FEAT will give you. And then you can also check the other hazard classifications that are related to this, but this is the most important one and the one that we have to continue. And the third case, if you don't have the name of the chemical or the substance, or you don't have the name of the type of facility, you can go and check the pictogram. And after checking the pictogram with different types of classifications like old symbols, UN transport, and GHS pictogram, you can find the hazardous classification, the hazard classification for the first priority response. So you write down this. This is the result of the first step. Do you have any doubts so far? Any questions?
Yeah, Diego, one quick question. The pictogram, is it on page 41 or?
Sorry. Yes, it's in page 53. I forgot. Yes, in page 53, you will find the pictogram table. There are two parts.
Okay. Right,
this
great, wonderful.
Table has two parts. Thank you. Yeah, thank you for this. And the hazardous table operation has 6 parts, as you can see here, and the substance has 9 parts. So you can see the magnitude of this, and this is the short version. So the big version is, you will see how big it's the amount of the number of substances we can find there. Then we go to the second step. After we write down, let's say, Flamlic 1. On the second step, you need the quantity, because according to the quantity, you can get the number of the distances that could be affected. And there are 2 methods for this part. A quantity table, and preferably through people who know the operation. If you have surveys of the tanks, what is the capacity of those tanks, for example. But in here, because we don't know the operations right now, we're just doing an exercise. We go to the quantity table that will help us get that information. If we go to the quantity table in page 39, there is a summary of common storage capacities for different type of industries. So for example, we're in an industry that has a small storage tank, and these small storage tank are usually, you have to be very careful with this, handles or stores 1 million kilograms of any chemical. And if there is a continued release, it is assumed that would be 1 kilogram per second. But in here, from this table, what you need to get, or what you need to extract, is this, the quantity in kilograms. 1 million, 10 million, 100 million, 20,000, 50. So for example, if you know that they manage drums, it's 200 kilograms per drum. And let's say it's a medium capacity industry, and you have documents that they've been having, let's say, 50 drums per room. So you can start doing calculations with this, and then you calculate the total amount. Juan Carlos is going to explain you a really good example at the end of, how do you make calculations if you don't have, let's say, exactly the size of the quantity from the facility. And the third step is to determine the exposure. So in here, you have to consider some field observations if you can, or maps of observations. So you need to check either rivers, settlements, lakes, drinking water sources, agricultural areas, climatic conditions, wind speed, direction, and everything that could affect the dispersion of this chemical in this place. Because in here, this is where the FEAT will give you the number, the distance, and the radius or the length of the river that would be affected, or the amount of, or the distances where people could be killed or harmed in their health. How do you do this? So you go to the exposure distance table, which is the page 57. Yes, 57, right? Page 57. And depending on the names we typed down before, if you remember from the hazard classifications, that they had like weird names like FLAM, aerosol 1, or FLAM leak 1, 2, 3. Depending on these that the FEAT gave us before, we take this row and then we go to the quantity. And depending on the quantity, the FEAT will give you their result. And this is what we need. This is what's very important, in that if you start calculating it by yourself, it's going to take more than the time. We just explained this because of the equations and everything you need for dispersion in water and everything. So depending on this hazard and the quantity, you have now the distances, and that's the result from the FEAT. So let's say you have an emergency, it's FLAM leak 1, 2, 3, and you have this approximate quantity. You know that you have to probably evacuate people around 400 meters from the spill point and 600 meters to avoid problems in health. Because under 400 meters, it's going to be a lethal effect, and for under 600 meters, it's going to be a health effect for the people. But you will see, okay, well, what's going on with the environment? So in here, the FEAT didn't provide the numbers because as this is a flammable substance, it would not affect the soils, the lake or the river, because they're like in water. But you have to consider if you have big animals, you have cows or something, you have forests that could be could become a wildfire. So this is an approximate estimation, but you also have to consider other elements that could be around. And this is to start, but these numbers are very important because you already know what are the safe distances and what are not the safe distances, from the spill points. And then you go to the checklist, which is on page, I forgot the page. If someone can tell me, please, in which page is this? I think is after the page 57. So that would be after 5 pages of this, because this has 5 parts. If you go to the checklist, you can input in here the type of hazard label. In this case, is flammable, and it will tell you the pathway and the receptors. In this case, it is telling you that the receptors will be human and critical infrastructure. But you should also put your thinking and start like, okay, but probably agricultural areas may be affected, and if there is a natural reserve so close by, could be affected also. And that is kind of like what you get the information, and finally you put all of this in a table where you put the operation type, the name, the hazardous substance, the classification of the hazard, which were these weird names with health CARC 1A or FLAM leak 1. Then you put the physical state, you put the quantity, the probable receptors, and the impact zones. So from the 3 steps from before, we put in here the hazard, in here the quantity, and here the exposure. This is the result from the FEAT, and that will help you map the possible areas that could be affected by different types of spills of different substances. And finally, the final step is to check that there is coherence in the results. You also should check the effects upstream and downstreams of the event, because everything is assuming a flat surface, but of course, there's hills, slopes, and everything that could change these estimations a little bit. So you should also consider this. What are the consequences around, if there are hospitals, schools, any settlements that could be affected, or any protected areas. You should also always check what is around, and with this information from the FEAT, make a more in-depth analysis. And finally, you can modify the table with other columns. For example, what we do is to have 2 columns for latitude and longitude for the coordinates. We also add an extra column for comments or links that will help the people in the ground or people that are doing the analysis to get more information on what is going on or what is in that place. Now, we're gonna do the step-by-step for the bigger version. But before that, are there any questions so far? Okay, so now you can go to the latest link I sent. Oh, thank you, page 67. That was for the for this table. Let me see. Okay, so now I'm gonna start explaining the first version, the bigger version, 2009. That's not the pocket guide. This is like desk, because it's an A4 size book, longer with more chemicals, but it's this link that Catalina pasted. So if you go and then open it, we can follow the steps in here. So the first step on this guide is to use the substance lookup table to search for a specific substance. Remember, the first step on the pocket guide is the same, but in this case, we need the exact name of the chemical. Why these or why the pocket guide had 2 more options? Because in cases of emergency, it's really hard sometimes to know which chemicals is specifically leaking. So you can kind of like know, depending of the type of facility or the labels, to know more easily what are the hazards. But in this case, you need the specific substance, and it has 4 parts: gases, liquids, bioaccumulatives, ice, that's in Spanish, sorry, and unclassified. In there, you determine the hazard type, like in the first step for the pocket guide. So if you go to page 41, you will find the first part. In page 48, you will find the part 2. In page 62, the part 3, and in page 66, the part 4. Okay, this one is in Spanish, but in approximately in page 66, the part 4. So let's say you have this substance, which is called bromo-3-methylbutane, leaking, or you're just preparing and you're mapping all the industries around, and you know that they use 1-bromo-3-methylbutane. What is the hazard type? In this case, because there are so many chemicals in this book, in this version, they used different type of names. Instead of leak, flam 1, 2, 3, or aquatic, chronic, TTD, they use these little short names like LF1, and that's what you write down and you save it. For example, in part 2, toxic liquids, you have epoxy 3-ethoxypropane. You type down LTA5LF1. Those are the hazard types. For example, for part 3, which are substances with persistent bioaccumulating or carcinogenic, mutagenic, and toxic properties, let's say you have asbestos or mercury. You type down CMR2 and PB2. And after typing those, you go, okay, in the part 4, there's no classified substances. So let's say you have clorodifluorometano. I mean, sorry, that's a picture in Spanish, but you type down this code, G and R. And then when you type down any of these, depending on the substances you have, you go to step 2. And then you go to table FT3, Facilities and Objects Assessment Modules, to determine the impacts on humans and nature. This is on page 36. It's before. It's weird, but it's before. So you take down this little short code. For example, we had GT4. It's a gas toxic to humans. And depending on the quantity, in this case, the quantity, it's also has to be known with more precision, because as you can see here, we have smaller quantities, 200 kilograms, 1,000, 10,000, and 50,000. And I didn't mention how to calculate the quantities here, because usually when you use these bigger tools, because you already know a lot about the facility. And that's why this is more a desk desk tool instead of an emergency or field where you can just calculate with approximations. So if you have, let's say, for example, 200 kilograms of GT4 high toxic, the distances that would be lethal for humans would be 20 meters and 950 meters in terms of health effects. For the environment, in this case, would affect large animals, and the little red square it means equal to human health. So it's a similar process than for the pocket version, but in here you can see that you can find more specific results. Quantities are smaller, so will give you more or smaller distances that are critical for the humans and for the environment, and that's the result. Getting the code, putting the amount, and the result would be the potential impact in meters. And the step 3 is to check the relationship between the hazards and the exposure. If you use the likely scenarios table, you use it to understand the relationship between the hazards and the exposure, the pathways and the receptors, considering that the exposure decreases with the distance from the spill point. So when you are checking these distances, for example, 200 meters would be a radius of 200 meters around, and then it will decrease how the hazard would affect. So as you can see here, 20 meters would be lethal, but after 20 meters, between 20 meters and 950 meters, would have effects on or impacts in the health of people. And this likely scenarios table is on page 21. And you can, in here, depending of the classification, like GT, LTE, this little code we got from before, we can see the relationship between the relevant receptors, the relevant pathways, and the potential impacts. So for example, the relevant receptors in here would be human, fishing areas, surface water, groundwater, agriculture, nature reserves, rivers, lakes, or coasts. The relevant pathways include air, soil, groundwater, lakes, river drains, human and animals, because both human and elements can be pathways when there is a bioaccumulative effect and other effects from specific chemicals, and then the potential impacts organized depending on the priority. So in this case, for example, with toxic liquid, the first priority would be the impact in life support in nature. The second one would be human direct. There would be a direct impact. And finally, the long term on humans and life support. And those are the steps for the version of 2009, which is the bigger version. But you should also have some considerations for the FEAT analysis. And this is where you're very important, because you need to analyze the sociocultural aspects, the political conjunctures, the geographical, hydrological, geological, and meteorological and historical aspects that may have relevance in emergency or disaster situations. You should collect information on the economic and industrial sector of municipalities and communities at risk of emergency. You should also check the impacts of past disasters and emergencies, the types of responses that were provided, lessons learned, and exchanges with other governmental entities. And also have location available of infrastructure, hospitals, schools, shelters, protected areas, river, lakes, agricultural areas, everything mapped. And that's why we suggested for you to have the column of coordinates. So by every facility, you know where it's located, you can make a map. And as we're going to show you in a moment, we're going to show you an example of emergencies where the FEAT was used to analyze the impacts on human health and the environment. here in 2018, we mapped oil wells, because there was one of those oil wells that you can see in red exploded and started leaking petroleum in one of these little creeks. But this creek had other creeks coming in, and this creek where the oil spill was happening had was draining to a river, a main river that was draining just less than a kilometer from here to the second largest Colombia. So after mapping the information, so you're having these coordinates where the oil wells are, the gas stations, the asphalt plants, for example, which are these pink, the roads, the communities that are like the zones with zonas pobladas, where people live. Sorry, I forgot the translation in English. And then if you could zoom in a little bit, you can see how all those oil wells could affect people and the environment. And then you know that in here you have one oil spill with the FEAT and the quantities estimated, you will know the length of the creek or the river that could be affected. The other case was also in Colombia, in Providencia, last year, no, in 2020. Yes, 2020, 2022 already, where hurricanes Eta and Iota affected this island in the Caribbean. This is close to Nicaragua. Let me see, here's the map in here. And we collected information for airports, waste management facilities, electrical services, gas stations, hospitals, ports, and industries. And the chemicals or substances were kerosene, benzene, diesel, petroleum, ethylene oxide, petroleum, and we mapped everything like this, and which is very helpful because it helps you identify where the probable risks areas can be, where to locate the efforts, maybe where to put some containment barriers, where to move people away temporarily so they probably won't be killed or affected in their health. So this is very useful because it gives you the distances, and you can map the points where everything is located that could be hazardous for the people and the environment. Now, we're gonna go to the existing information in Latin America and the Caribbean, and the work that we've been doing last year with Juan Carlos and Catalina, collecting information from many countries in the region, but Catalina is gonna ask you for information that we really need in order to conduct and to have more updated and more data from you. So Catalina, please.
Hi, good morning, everybody. Diego, can you change, please, the slide? Okay, so what information do we have in this moment, and what information are we missing? Please, Diego.
Okay, there you go.
So in 2021, were created the FEAT tables of Argentina, Chile, Uruguay, Barbados, Suriname, Mexico, and Peru. Before 2021, we didn't have any kind of information regarding these countries. And then, Diego, can you change the slide, please? And then also the FEAT tables of Trinidad and Tobago, Costa Rica, Belize, Dominica, Antigua and Barbuda, and Cuba were updated also in 2021. Please, Diego. Sorry, it's a little bit slow changing. Thanks. And the FEAT tables that were created before 2021 that we have some information were the tables of Ecuador, Guatemala, Panama, Honduras, Paraguay, and Venezuela. We have more information about the different countries, but in this moment, I'm just mentioning in the case of the tables that were created before 2021, sorry, are the tables that are of the member countries of the EEB network, but we have other tables for different countries that are still not member of this network. Can you change Diego, please? In this moment, the only tables that needs to be created in the whole region of Latin America and the Caribbean are the tables, the FEAT tables of Santa Lucia and San Vincent and the Grenadines. But can you change Diego, please? But where does the information come from of the FEAT tables that we already have or that have been updated? So mainly from secondary information, from the internet, and especially from the tool Hot Export tool that we have been using for updating and creating the tables that I mentioned in 2021. But we can improve these tables with your help, and this is the information that we are kindly asking you to provide us, and is the information that comes from the Ministries of Environment and the Civil Protection Ministries, the National Geographic Institutes that, for example, give information about the use of soil or different kind of industries that are in the country, or, for example, where are located plantations and this kind of operations. And also the Ministries of Mines and Energy, where we can have information about the location of mines, the different kind of mines, and the substances that they are extracting or that they are using, or the subproducts also are important to take into account. And other ministers and institutions that maybe you have in your own country that can provide this useful information. Can you change Diego, please? So this is how it looks, the FEAT tables that we have so far. Mainly we have the site name in case that we have. Not all the time we have this kind of information, but the most important part is to know the latitude, the longitude, and also the site type. This site type was classified according with the hazardous operations table that Diego mentioned before. And according with this information, we obtain the substance, the most likely substance that can be present in this kind of operations, the hazard classification of the priority response, the physical state of this substance, and the quantity. And this quantity that we are putting in these tables is very conservative. We are using the maximum quantity that appears on the tables, and also the receptors, the risk type, and the impact zone, both for when it's lethal for humans and where represents a hazard for human health, but also for the environment, for the soil, for the river, and for the fauna and flora. But the problem with the tables that we have right now, as I said, is that we are using the information that is on the tables. And even is a great approximation in this moment, is very useful to have real data, because the only thing that we can know for sure is the latitude and the longitude and the kind of operation, but we don't know exactly what kind of substance is in there, and we are assuming certain things. But if you can provide this information, we can have better information and not do overestimations or underestimation, because of course, even if we have different kind of operations, it's not always the same kind of quantity, and it's not the same kind of hazard that represents a small operation, I don't know, for example, from aquaculture, or a large operation. So it is very important that you help us with this kind of information. Diego, can you click, please, to show? So as I mentioned, it is very important for us to have the site type. This long list is just showing some of the hazardous operations that appears on the FEAT table of the pocket guide that we share with you. And yeah, this is mainly what we are asking for. I don't know if you have any questions about what information is the kind of information that we are requiring in this moment. But of course, if you have any doubt about that, you can contact us in any moment. Thanks, Diego.
Thank you, Catalina. So as Catalina mentioned, do you have any questions regarding what type of information do we need? Because for example, this table we're showing right now, well, the type of industry and facility, we got it from the internet, and then we use the FEAT Pocket Guide to estimate which substance probably they use and the maximum amount. But if you have more specific data, this will help us more, and also we can jointly work. We can also, we need to share with you, Catalina, can you please share with everybody the training course? There is a training course for this FEAT tool. It's in English. It's a 4-hour course. It will give you your certificate if you finish it, and you will be capable to use any version of the FEAT tool and start creating this tool. We can also give you the tables, how we have them right now. We have your country here developed, and you can continue working on those because there's a lot of work to do and everything. So if you have, please let us know. If you have any questions, open your microphones, let us know.
Diego,
Yes.
if you could post in the chat the location for the FEAT tables for Trinidad, that will be useful for us to peruse.
Okay. We have the FEAT tables right now. We have them all over United Nations OneDrive, but something we're trying to do with the network is to have this website of public information where we're gonna post all the information we have related to the network, and everybody can access it. What we can do is after this webinar, we're gonna share with you the latest files on a personal drive, because in that way we can share it, because the UN drive doesn't allow to share it externally. And then when we have the website developed, we can have direct link to the latest updated tables. Does that works for you?
I was wondering if you could share what you have developed so far for Trinidad and Tobago, so we could, while you're working on the website, if you could see that.
Oh yes, we're gonna share after the webinar the tables we have updated so far. Well, we put them on the website. And okay. Yeah, definitely. We can share with, for example, the Trinidad and Tobago tables with you, so you can have them and start. I mean, you can start playing with it, putting information, testing some specific information we put, or we start putting new information. Yeah, definitely. That's public information for you, for you to use. Yes.
Okay, thanks for that.
You're welcome. So I think we can continue, and now we go to the study cases. So Juan Carlos, please, he's going to show you some examples, some real cases, and let's see if we have enough time for this. So we can show you all the examples we worked on for you. Juan Carlos, please.
Thank you very much, Diego. Can you please click on that? Well, welcome everybody. I hope you're having a fantastic morning. I would like you. First, I would like to thank Diego for the introduction and for that brilliant presentation he made about the steps we need to characterize the kind of hazards we have. As Catalina mentioned, we've done this onto these tables we've gathered together, and I want to start this conversation, and I want to highlight conversation because that's what I want to do. Just making some real case studies, but trying to do it in a methodology that is a bit like a study problem. So for this case, I have a lake. This lake is in China. It's a real case. Can you please click, Diego? This was a documented study from China on Lake Tai, and it happened to be high concentrations of pesticides that have been found in the Taihu Lake in the Wujin district of Jiangsu province. Sorry for the Chinese accent. Due to diffuse discharges from aquaculture, poultry, and dairy farms and sewage treatment plants. What industry polluted discharge to the lake? Is it prioritized to reduce and control? That's the question that it is posing this frame. What actions should be taken? That's the second question. Can anybody tell me what's the first step for using the pocket guide in this story problem? Anyone just want to guess?
The chemicals of concern, the specific chemicals.
Wow, that would be difficult because we have diffuse discharges. So we don't really know what the chemical is. What you do if you have the pocket guide? Sorry, what would be the first thing you do?
Look at the industries, the industry profile.
Correct. That's the correct answer. So Diego, can you please just click? So determine what industry discharge creates pesticide pollution in the lake. So then we have to go to the hazardous operation table. I've just broke here the big title of the table, and I broke some of the sectors of the facility types that were included. I didn't bring the whole table, but I just cut it and paste the those sectors that were mentioned in the story problem. So I broke here the aquaculture type, operation type, the livestock operation type, the wastewater operation type. Both first, aquaculture and livestock and poultry are included in the agriculture and food production. Sorry. And the wastewater treatment operation type is included in the infrastructure and transport facility types. Once I just gathered this information, there's a lot of information that it's being brought to us in the table. First, we can see in addition what other most common substances are released normally in the operation of these facility types. Uh, it can tell us as well about the most common substance. That's interesting when I have the most common substance because this brings me an idea of what should I focus on. In this case, in the case of aquaculture, I would have as most common substance antibiotics and wastewater treatment, which has as main common substance methanol, are not pesticides. So I made the first easy and fast step, which is determine which industry, which kinds of facility I should um, first oversee first. Click. Can you please click? So I have this industry of livestock and poultry, which uses carbamide, which is a pesticide. It's normally used in poultry industry more than in the livestock industry. And this, I assume, according to the story problem, that might be the most significant source of pollution in the lake. So what comes next? I have uh, I've determined what kind of industry is that on which I would make some in-deep analysis, and I've got a substance about a pesticide. So then I know from the table that the pesticide is used in a solid way. Oh, sorry. And then I have uh, a declaration of what kind of hazards this pesticide can pose into the lake. It seems that it has more than one kind of hazard classification. It includes aquatic acute 1, aquatic acute 4, acute toxic 4, and carcinogenic 2. As you will notice, there's a number after each of the hazard classification. It mostly of the time determines what is the impact or the priority of the impact. However, what it comes from the table itself, it says that aquatic acute is the first impact that I should address for this kind of pollution. Can you click, please, Diego? However, uh, just having in mind that aquatic acute is the first hazard, it is useful, prudent, I said, to conduct an examination of the amounts of carbamate used in poultry farms. So this brings me an idea that I need to do more because the next step will be, anyone can help? What would be the next steps from just recognizing what the substance of interest is in this story problem, the one who I need to address first?
Quantity.
Wow, too much silence.
Quantity.
Sorry again?
Quantity.
The quantity, of course. So, Diego, can you please just click? Oh, so I should go to the exposure distance table. Um, what I would say is I have three uh, quantities I need to address. So I have carbamate that has a hazard, which is aquatic acute, sorry. And I have three kinds of quantities that poses different impacts on environment in this case, since the carbamate is being drained into the lake. Which quantity you think I should pick? Any insight? Okay. So since the story problem says that I have diffuse discharges into the lake, what I need to assume is that I don't know how much of the carbamate has been drained into the lake. So probably I have some concentration in some parts of the lake. I can go and measure what the concentration is in different parts of the lake. But what I should suppose is that the carbamate has been drained for long ago. So maybe since it is solid, there are places where there's higher concentration, other places where there's not much concentration, or it is a deeper place. So I would first, can you click please for Diego? I should go for the highest amount of carbamate that has been drained into the lake. This makes me a bit cautious. This can be a really really conservative measure, but in cases of uncertainty, I should address the first or the highest quantity. If I just pick this quantity in this moment, I would immediately know what would be the precautionary measures that I should take into determining um, the hazard to the population or to animals or to the wildlife. So it brings me, can you click please? It brings me a distance. That's the solution for this problem. I have a distance in which I can just propose precautionary measures in an area from, as Diego says, from the spill, from the focus of the spill, uh, 2.8 kilometers around, which is 2,800 meters. um, It is interesting that I also receive more information in case the carbamate is drained into a river, for example. I should take a bigger or larger precautionary measure. I should seek for just making preventative measures on 10 kilometers um, on the river, and also in soil, because as Diego explained, the carbamate as a solid can be drained either to the lake or to the soil when rain comes, and it can infiltrate into the soil to pollute deep water. So in these cases, I have also precautionary measures to take on 10 kilometers around the spill. However, I have not, in this case, a point where the spill was made. So I should focus on the length the farm is in contact with the lake, and this would be my point of discharge, since the discharge is is a diffuse discharge. Sorry. Um, if also Diego explained that if I have the discharge into a lake, what the feed tables su suppositions, presuppositions they made is that the lake is 1 meter deep, and well, you just make from the point where the spill was made cylinder of 1 meter deep around the lake. In this case, just suppose that that the average deep depth, sorry, from of the lake is 2 meters. So the area to be considered to restrict is inversely proportional, which is if I have a 2.8 kilometers length or radius from the spill, I would rather, if I have a 2 meter depth in average in the lake, I would have 1,400 meters of precautionary measures length. Sorry. Just can you click, please? The last thing I should do is just register information, the feed tables. What we present, what Catalina present, is just the matrix that we use for just including this information. Can you click, please? And it starts with these names. First, okay, the name. Can you click, please? Diego, thanks. Which we would rather prefer that it is a name that is easily to identify by authorities or the Chamber of Commerce, in case we need to do deeper in the intervention into the farm or the spill or the place where the spill was made. Secondary, we have the site type that we found from the feed table. Can you click, please? So we take this livestock and poultry operation type, this into the this cell. It's taken from the hazardous operation tables. Can you click, please? And finally, in this first part, we just include the coordinates of the site in decimal degrees. That's what we expect that made a better characterization of the point where what we are researching in this case. Then we just include the characteristics of the spill. So the carbamate is pesticide. Carbamide pesticide is the substance what we are looking for. That's also taken from the hazardous operation tables. Can you click, please? We know that the carbamide pesticide is solid and it poses an aquatic acute 1 hazardous class. We also record the highest distance since we don't know the real quantity that was discharged into the lake. And then we just determine what kind of receptor is the main affected. This in this case is the environment and it affects aquatic life and soil. We also have seen so far no impact on human health or human lethal activities. So at the end, we just record the distances that are suggested for the substance. Just one more click, please. On these distances, what we are trying to make is that we have a precautionary area where we act just displacing people or avoiding some kind of activities on this area. Okay, let's go with next.
Juan Carlos, qué pena. I'm sorry.
Yes, sir.
Should we go to the last example like yesterday? So we kind of like get on time. The fourth
All
example.
right.
Marine mopping. Oh, whoops.
Just can go one slide before.
Yeah.
Okay. There's some more examples. This was easy story problems that we just developed for the first examples taken from the FEAT table on the Pocket version. We would like to use in this case the larger version of the FEAT tables. In this case, we are supposing a story problem. Can you please click? Which is this. I will read it. 3 articulated tank trucks, 43 feet long, 3R2 loaded with benzene, were involved in a car accident and fell from a cliff of a coastal highway onto a river near its mouth in the Caribbean Sea. The mangrove in the river's delta has been designated as strategic because of the large number of species that live there. The benzene slick has reached the sea and is being rapidly dispersed by the Gulf Stream, threatening new habitats for marine species. Fishing in the sea has been completely disrupted. Cases of people fainting due to gases are beginning to emerge in a small coastal town of fishermen, and large number of bird species have been threatened. Your unit has been tasked with devising a plan to deal with the contingency. Okay, so according to what Diego just showed before, what would be the first step for using this version, this large version of the feed tables? Wayne, you have been very active here, so I expect you just have an insight for us.
Sorry, I missed that one. What's the question?
The question is what your unit has been tasked with devising a plan to deal with the contingency. The contingency is 3 trucks just slick benzene into the mouth of a river that just is in the Caribbean Sea. What
Right,
would be
so-
the first step for determining what's the impact of this car accident?
Well, we know what the chemical is, so it's benzene.
That's
So we go to
really
the
true.
lookup. Yeah, we go to the lookup table and we get the the code, the risk code from the table, and then we use
Correct.
that.
That's Badnek. I didn't see the. That you are very right. So can you please click on the presentation? So pick the right model. Oh, sorry. What this table suggests is first having a way to look at the tables, but just 3 clicks away, please, Diego. Correct. So let's go to substance table. So I just put in the titles. We have the substance. We now know that we are dealing with benzene. The hazard type. We have these kind of types, and we have the UN number. What is this kind of hazards? CMR2. That's carcinogenic, sorry, mutagenic, and reproductive toxic. And it deals with the scale from zero point 0.5 to 2. And then we can see that we have a big deal since we are dealing with the top of the impact for this kind of hazard. Then we have LTE, which is liquid toxic, and this is 2, and it deals in a scale of 4. So it's medium impact for liquid toxic. And we have LF, which is highly flammable. It deals also with the scale of 4, so we are dealing with um, uh, medium flammability for the substance. So this is the first step. Okay, now I know what's the impact that the hazard or the hazard that the substance poses to humans and environment. And the second step is, can you please click, Diego? Is okay. Let's see what the likely scenarios for this kind of substance. So what I did is just bring here to show what these impacts that was named in the hazard type section of the substance lookup table. First, we said persistent and accumulating substances, which is CMR, was carcinogenic, mutagenic, and reproductive toxic. It's the first one that we have here. So that's the global name is persistent and accumulating substances. And it says in this case that the first effect, you can see that in the right uh, in the right down part, I have first high priority, medium priority. It's the classification of the hazard. So the first um, hazard of or the main action of that hazard is long-term hazard. So it is accumulative for this kind of substance. It also, in most of the cases, is a consistent hazard. So it is continuously releasing a hazard to the population or the place it is built. Um, for
Juan, can I
the liquid
interject?
toxic, it's the next one, toxic liquids to human environment. We see that we have a first impact on the environment. So life support and nature direct. It's the place where the substance causes a major impact. And in this case, we find that the consistent impact is on fishing areas, is also on rivers or lakes, and the relevant pathways where the substance is distributed is lakes or rivers or drains.
Juan,
And
could I?
finally, we have this toxic gas, which is flammable, combustible, or small in small containers. And we find that as a flammable substance doesn't pose a high priority impact. It doesn't have a one in this in red, but it poses medium priority impacts to humans and to the environment. So I can,
Juan
with this
Carlos, sorry,
table,
I
just
think that,
make a profile. Sorry again, see?
sorry,
Fine.
Juan Carlos, sorry to interrupt you. I think that there is a hand, and I think that Mr. Wayne wants to talk.
Yeah,
Okay,
Juan,
good.
yes,
Wayne.
yeah. A clarification. The lookup, the substance lookup table on in part 2 of the document, the FEAT version 1.1, under toxic liquids. I'm looking for benzene, and I'm not seeing benzene listed as a toxic liquid in the table on page 50. Could you?
Oh, yeah. Okay, just let me see. What page are you looking for?
Page 50.
Just give me a sec. I'll just go to my table. Sorry, I'm just. Pocket guide. No, this is FEAT version 1. Okay, the Flash Mathematical Assessment tool. And you said page 50. Okay, under toxic liquids, you said. Right? I remember I had the same problem, but I just finally, 1 week.
I think it's because benzene appears in part 3, substances with persistent and bioaccumulating or carcinogenic,
Correct.
mutagenic, and reprotoxic properties. It's in page 62.
Page 62. Page 62.
Yep, that's it. Page 62, part 3, substances with persistent and bioaccumulating or carcinogenic, mutagenic, and reprotoxic properties. Page 62, after asbestos, white, I think it says.
Right, I'm seeing it there. I'm seeing it there, but maybe some sort of maybe some notation to guide you to that's a specific section, because it's classified as a toxic substance, but it's
Yeah,
toxic.
that's true.
Yeah, so it maybe
So
to say
this,
it should say for mutagenic characteristics or whatever. See part on page 63 or something like that, so that
yeah,
it guides
maybe
guides
it's
Yeah.
the
not.
Mhm.
guides the user to the relevant section.
Yeah, in the first part, maybe it is the title is lacking. However, what you see is that I took the benzene and I took the hazard type, which is in page 62. Now you can see it. When?
Where you have where you made the change.
No, I've not made the change yet. But Diego, can you just go back one click or
Yes.
two? This is what you find in page 62. Sometimes it's not easy just to find what the substance is, but now that we have the substance, the easy way of finding it is just going through all the substances included in this substance lookup table. And as you can see, it started in page 41. I've just made a search through just Control F tool in the keyboard, and I found it. So this is one way of doing it. Sometimes you just find the characteristics, and if you just click Diego, what we would find is the likely scenarios. And in the likely scenarios, we have one more click, please. These titles of persistent and accumulating substances. This is the CMR 0.5 to CMR 2. So this is what we are trying to just pick in this moment. What the hazard type are bringing a hazard to humans, long-term or life support nature. Is there any other question, Wayne?
No, that's okay.
Do you have a definition for high, medium, and low priority?
Oh, well, actually, what it was done is just making what the most relevant impact of the substance poses to the different medias. In this case, for example, the CMR, it looks that it poses an impact on the accumulative uh, process of the substance. So in this case, we are, or the FEAT table just leads you to look into the priority that makes this long-term impact on the of the substance. Sorry, I've I've not a real very proper definition for this, but what it indicates is that the cumulative, in this case, the cumulative effect of the substance should be taken in a closer look. I think this is what the one high priority definition could be useful for. It was a good answer for you.
Well, it's the only answer you have.
So far, yes, that's the only answer I have. Okay, let's continue on this. Maybe that will bring a deeper insight for you. Can you click on this? If once I have these priorities, um, the 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 next action is just to have what facilities and objects are being impacted for the substance. I have I brought here three of the impacts that each impact hazard is proposing. It seems that the 5,000 kilograms quantity that it is defining the distance what in what uh, the action should be taken. So so far I would have impacts on life support, and it's 10,000 meters from the spill, which I would make a precautionary measure for the environment, and it proposes 650 meters for the toxic gas um, impact hazard for distance as a precautionary measure. Can you please click, Diego? Okay, so these are the distances. Sorry, again. Click. So what I should first is that now I have a quantity and a distance that I should propose a precautionary measure. Then I would look for the exposure, and the exposure it's being framed more in what it is happening in the region. So just click, please, Diego. Then I have the exposure that the highway just the car accident was made on the highway. Just me be looking at the mouth of the river, and it just pollutes the sea. But also the population is being affected, as well as the mangle section in the mouth of the river. And then I'll see for the quantity that it's being uh, spilled into the sea. There's kind of tip in the story problem that says that the truck was 43 feet long, 3R2. Just one click, Diego. These are the 3R2 trucks. Three is for the three first uh, axis of the truck, and two for the two lating axis. So this makes me in the tables of transportation, I can see easily what's the maximum storage that can uh, drive these trucks. It says that it's 200 barrels, and the problem says that three of the trucks were involved in the car accidents. Um, 200 barrels are 31.8 cubic meters, which is each one of the trucks. So at the end, I would end up with a total spill of 83,818 kilograms that were spilled into the sea. One more click. What I can see is that the 83 and 818 kilograms is 16.8 times higher than the typical quantity that was depicted in the table before. So the distance should be modified according to the length of the spill, pardon, and then can you click, please? I would have to adjust the distance according to these factors that modifies the distance. So I just look into one more click, please. If it is 16.8 times higher, so I just approximate the 16.8 to 20. So I would just multiply the distance for the factor 4.5. And this would give me 22.5 kilometers around, not the 5,000 meters that was firstly um, appointed by the table. And this is far shorter than the, can you one more click, please? Than the one suggested. If just make a more in-depth research into the tables, I find that the benzene in table 2, it suggests uh, um, um, just a precautionary measure of 5,000 kilometers, 50,000 kilometers, when the impact is a direct impact to humans. So since the distance I just calculated through the adjust table, the distance factors tables is shorter than 50 kilometers. I should just one more click, please. Okay, that's what I said. I should just make a bigger radius of 50 kilometers of the area from where the spill was made. So the final input is just this area of precautionary measures under the sea, considering that the Gulf Stream is also affecting, it also is affected by wind speed in these areas, depending on the area of the time of the year, and other factors that affect makes me as a expert consult um, just make a broader area for determining what impacts are being proposed. I think that's the end of the story problem. Any further questions?
Juan, could you just go back one slide? One slide. Right. So so your quantity factor. All right. So you determine that the quantity of the benzene is 83,818 kilograms. And then you said you use expert judgment to a quantity factor of 4.5 by the distance. How did you arrive at, where did you get the quantity factor from?
Yeah, as you can see, can you go back a bit, Diego? A bit more, where the distances are. Yeah, that one, no? Okay, distances are. So I have 5,000 kilograms as the limit of the amount that is proposed in the table. But now I have a spill of 83 tons, 83,000 kilograms spilled into the sea. So the factor, if I just divide the 83,000 kilograms by these 5,000 kilograms, it gives me 16.8, a 16.8 relationship. I mean, it's a 16.8 factor. Now just can go further, Diego. This is 16.8 factor. Is higher than the typical quantity. So I don't have a 16.8 in this quantity factor table. Just approximate to the highest factor, which is 20 times factor, and it leads me to a multiplication factor 4.5 of the distance. Is that clear?
Where's this table? This table is referenced where? This where you
Yeah,
get
just Catalina just made the reference in the chat where this table is.
okay, so yeah. And that is linked to the FEAT table.
Yeah, correct.
That is in the FEAT table.
There's an additional, Catalina, you have the link for
Hi.
this table?
Well, the part that is explaining about the tables when you can have different conversions factors is on the chat that I just put it. And the specific question, actually, this FEAT reference guide working document that is for the version 2.0, but it cannot be applied on this long version also. And always when you are using FEAT, can be downloaded in the link that I just put. And how do I determine the exposure distance in case the quantity when it's outside the range of the exposure distance state in the shortlist actually is one of the questions that are answered in this reference guide on page number 111. So yeah, you can find the whole table in there with the conversion factors. I don't know if it's that clear and if you can see maybe on the link that I just put on the chat.
Okay, I will look. I'm downloading it now. What page is that?
111.
111.
Actually, this guide, this reference guide is very useful. It has in the annex number, I think that is the annex number 5. Yes, in annex number 5, there is very useful questions with questions and answer related to all these FEAT tables, including these conversion factors. Because it's not like a rule of 3. You need to use these factors, these multiplication factors.
What page 100 on?
111.
Okay.
When you put in the PDF. Is the question number 9.
Okay. All right, I'm seeing the table now. Okay.
Okay, perfect. Yeah, it's just that you have to do the conversion. Normally you can use the FEAT table, but this is very useful when you have a little bit of extra time if you can do these conversions, especially when you don't want to over or underestimate the exposure distances.
Okay, thanks.
You're welcome. Do you have further questions maybe regarding with this part?
No. We won't. You know, this guideline document. You know, would be useful to go through.
Okay.
Yeah.
Anyway, if you have further questions, please don't hesitate to contact us at any time.
Okay, thanks for that.
Okay, so are there any more questions from the participants? Any comments?
No, I think Diego, I think is a useful tool to use. I mean, as you said, it's an estimate. You need to use it with expert judgment and actual information that you get from field investigation, but it is a good tool to apply in any particular country to see, you know, to assess your risk from potential releases of, you know, toxic and hazardous chemicals. So I think it's something useful, very useful.
Yes, definitely. Yeah, thank you. Thank you for the comment. We usually use it in response emergencies, but we have deployed team on the field as a remote support to create the tables for specific places in the country, so the areas we were affected by or the disaster occurred. So I'm gonna put in the chat the latest updated table we have for Trinidad and Tobago, for example. It's on my personal OneDrive because the UN OneDrive doesn't allow to share externally again. So you can download it there. It has a lot of rows, as you can see. Just please let me know that you can access it and download it. You can edit it directly if you want. Also, if you want more information, please give us your email account, or you can write to us at my UN.org email or Catalina's. Just to say thank you for your time today. We're going to send you the recording of the meeting, the presentation, and if you have any requests for any resources or anything, please let us know. And please remember to also send us any useful information so we can update the table, because everything we've been working on has been using secondary information. Catalina, please.
Yes, Diego, just to actually was the last part that you said, just to remind you that these tables are with the secondary information. Of course, we had a part when we were doing a depuration of the whole information that appears on Hotspot, but due to the amount of information and the points that we have, maybe we have some points that can be misclassified. So if you find these kind of things on the table, please let us know. There's always a part on the tables that can be a column with comments or useful links. And just to remind you, all of you, to please share with us the information that we request when I was talking. It would be very useful to have this information in the case of the ministry, because in an emergency, sometimes it's very hard to coordinate with the different departments, with the different ministries, and just to have it in one place, it's very important and can save time and also make the response faster and the mitigation measures more effective. So thanks again for, as Diego said, for joining us today. And yeah, if you have further questions, please don't hesitate to contact us. And just to remind you, the FEAT tool is a first tool to use in case of emergency. But of course, you have to use and complement with other tools and with environmental impact assessments, especially when you are using in prevention cases. So yeah, thank you, Diego.
Thank you, Catalina. Thank you for this. Hopefully we can keep working together with more information, nourishing the tables we have so far. We have to create a few more tables from scratch, but we want to count on you to get this information. And again, thank you so much. Please, sorry for just getting a little bit more of your time. And we wish you a great day. I will send you this recording and the presentation as soon as we have it on YouTube. On the channel of the EEP network. Have a great day and thank you so much.
Thank you very much. Have a great day.
Okay, bye.